Hi, today we shall be developing Granger Causality test, and here we have two variables such as lending rate and consumption, and we assume that without checking that these two variables, sorry, not three, two variables are stationary or does not have a unit root. We just assume that our two variables are stationary or does not have any unit root. We assume that because the variable must be stationary in Granger causality test, right? Okay. Here actually our question whether consumption causes lending rate or the lending rate causes consumption. And here we have the model. This is our model. Cons means actually consumption, and here is LR. LR means lending rate, and this is our first model. And you can see C1 actually is the coefficient of the lending rate, and T minus I actually are the lags, and C2 is the coefficient of the consumption, and T minus J is the lag period, and UIT is the residual of the first model, and second model is the lending rate, and C3 is the coefficient, and C4 is the coefficient of the consumption, and T minus J is the lag period, and U2T is the residual. So meaning that here are actually four coefficients: C1, C2, C3 and C4. And here we assume that cons and LR variables are stationary. If they are not stationary, we need to make them stationary before testing Granger causality test. And here we assume that UIT and U2T are uncorrelated. Okay. So I can show you the data. Data is here, you can see from the 1970 until 1990, and this is the first variable cons, and the second variable is LR. So we have these two variables, right? Okay. Now first actually we have to develop the VAR model, and from this VAR model we can develop the Granger causality test. Okay, so we proceed to the statistics. So I go to multivariate time series, then I go to VAR model, Then here I click here, our dependent variable, it is not here, just I check. Okay, it is just one minute. Okay, from here, just 1 minute. From here, yeah, I go to statistics. Sorry. Okay, so I do it again. For some reason, it is not working. Okay, I choose this one. I go to statistics, then I go to multivariate, then vector auto regression, then yes, then I have two variable cons and LR, right? Okay, so here first I take lag 2. Okay, then I then in future I shall take lag 4 and also lag 5. So first I begin with lag 2 and see the outcome. And here you can see two model and model 2. So here I choose model 2 because because our sample size is very small, so I select these two because our sample size is small and we are wanting to see F statistics, right? Here uh, I want to see F statistics, and that is why I have selected these two. Okay, then I go to model, then I go to time settings. Okay, here I choose our variable OBS and the data is yearly data, right? That I select and then I press OK. So model is set now. So I click OK. So here this one is the actually VAR model. You can see vector auto regression model, and here you can see this one is the dependent variables, cons is the dependent variables, and this one is the actually this one is the lag of one cons variable, and this one lag 2 of cons variable, and this one is the lag 1 of LR variable, and this one is the lag 2 of LR variable, and this is coefficient, this is standard error, this is T statistics, and this is P value. Okay, and here we want to check whether whether lag 1 of LR and lag 2 of LR can cause cons or not. That we want to check, and here we want to check whether cons lag 1 and cons lag 2 can cause LR or not. That we want to check actually. Okay, so I go to statistics, then multivariate time series, then I go to VAR test, then I go to Granger Causality test, right? So I click here, I press OK, and this one is the outcome when we have taken lag 2. So this is Granger Causality test. And okay, first I talk about this one. Okay, here what is the null hypothesis? For the first one, lagged LR does not cause cons, right? That is the null hypothesis. And alternative hypothesis, lagged LR cause cons, right? So that is alternative hypothesis. Okay, here what does mean by lagged LR? Make sure here is two lagged, right? Two lagged variables of LR. Okay, here this is the F statistics. This is the F statistics and corresponding probability. So the probability is 11.40%, meaning that more than 5%. And when the probability is more than 5%, we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that lagged LR does not cause cons. Okay. Then here, what about this one? Okay, this one, cons, lagged cons variable does not cause LR. That is the null hypothesis. So I am writing here lagged cons. Here will be cons, right? Lagged cons does not cause LR. That is the null hypothesis. And alternative, lagged cons causes LR, right? That is alternative hypothesis. And here what is happening? The probability value is 47.52%, which is more than 5%. So we cannot reject null hypothesis, meaning that lagged cons does not cause LR. Okay. Okay. So now, so last time we take lag 2. Okay. Now I take lag 4 and see what happens. I go to statistics, then multivariate time series as before, vector VAR model. I select. So here I take lag 4, right? Here I take lag 4. Then I press OK. So this is my model, right? You can see lag 4. You can see there are lag 4, right? Lag 1, lag 2, lag 3, lag 4. Okay, this is my model having 4 lags. Then I go to statistics as before, multivariate time series, then VAR test, then Granger Causality test. I select it, then OK. Okay, this is the model. Okay, here you can see, so the story actually the outcome has been changed a lot. Okay, so here lagged LR. So what is our null hypothesis? Lagged LR does not cause cons, right? And what is probability value? 6.07%. So meaning that we cannot reject null hypothesis, meaning that LR does not cause cons. And here also the probability value is 19.33%, which is more than 5%. So we cannot reject null hypothesis, meaning that cons cannot cause LR. Okay. Okay, now I take lag 5 and see what happens. So I go to statistics as before, multivariate time series. Then I go to VAR model again. Then here I select 5 lakhs, right? 5 lakhs. Then I press OK. Okay, you can see there are 5 lakhs, right? 5 lakhs are here, lag 1, lag 2, lag 3, lag 5. Okay, then I go to statistics, then multivariate time series, then I go to VAR test, then Granger Causality test, then press OK. So this is the Granger Causality test. Okay, now you can see the result has been changed a lot. Okay, what is the null hypothesis? Null hypothesis lagged LR, but make sure here is 5 lagged, right? Lagged LR does not cause cons, right? That is our null hypothesis. An alternative hypothesis, lagged LR does cause cons, right? That is our alternative hypothesis. So here you can see the probability value is very small, only 4.15%, which is less than 5%, meaning that we can reject the null hypothesis and can accept the alternative hypothesis, meaning that lagged LR does cause cons, right? So the result has been just opposite. The result has been just opposite because we have changed the number of lag. But what about the second one? Okay, second one, cons cannot cause LR. Cons cannot cause LR because the probability value is 20.93%. So we cannot reject null hypothesis, meaning that cons cannot cause LR, right? So actually what is here we have learned, actually when we change the number of lags, the result changes a lot. So lag is a very important factor for any outcome. Okay, so lag is a very important factor for any outcome. So, but the question is that how many lakhs we should choose. That is the question, right? But how many lakhs we should choose? How many lakhs we should choose? We should choose for this model, right? So that is the question now. But in future I shall talk about lakh selection. I shall talk about lakh selection. Okay. Thank you very much for being with me for a while.